Hi everybody, this is going to be the final video for your covering your exam one topics. This is going to be computer architecture and organization. So this one is also a pretty um, not quite well tested on. It does get a little complicated. So yeah, I have some of the practice problems here. I'm not going to do the instruction translations just because I think those are quite intuitive. Like you just have to translate it from the instruction sheet. So yeah, we're gonna skip that and then we're just gonna go over the fetch, execute, and decode three-parter kind of thing going on. So yeah, these are from your practices. So you'll probably see a few of these on there. So yeah, I have four examples here for you guys. So yeah, let's get started. Okay. So for this, you're gonna need this set of instructions, right? This is included on Brightspace, and of course you'll have this for the exam as well. So if you go to Computer Architecture and Organization, under your V1 assignment, you'll see the Simple Machine Language Appendix, and that's where you'll find the translations here. So I don't want to keep um, switching back from Windows, so I'm gonna just screenshot this so I can have it in my notes. Yeah, those are, yeah, this is my daily wallpaper, I guess. Anyways, so, and I do have the answers included just so we know what we're supposed to be getting. Okay, go ahead, put that here. Okay, so yeah, let's get started. Alrighty. So you guys should have gone over this in class. There's three steps to this process. There's fetch. So I'll write them right here. There is fetch, execute. Oh, sorry. Fetch, decode, then execute. Right? So the let's read what this question is asking. So assuming the program is loaded at MAB, what is the content of register A in hexadecimal when the machine halts? All right. So this here tells us that we're starting our program at AB. The M here just stands for memory, and it's referring to the memory address. So here, this is what we're looking at. And then, like we said, we're looking at AB. So we're going to be starting right here. And that will be our program counter. I forget how to write that, but I'll just write AB right here. That's the place in memory we're starting at, right? And yeah, so the question will ask you where we're going to start at, and then you'll go there in the memory address. So here, all of these are just addresses and in memory, and then in those places in memory, all of this information is what's stored there, right? And here, all this information, that's where we're going to fetch our instructions, right? Okay. So we're looking at AB, and right here we see the instruction that's going to be 1A. And An instruction is worth 2 bytes. That's 4 hexadecimal digits. So that's why we'll also get 45, and that will be our first instruction. And in class, he'll tell you that your program counters update by 2, and that's just because we need 2 bytes for a full set of instructions, right? So after we've translated this and executed it, we know our next place we're going to start at in memory is going to be AD. So you're just adding 2 every time. So AB plus 2, that equals AD. Okay. So for the first set of instructions, we already did our fetch. So now what we want to do is decode. So how do we decode this set of instructions? Well, we'll use this right here, our opcode operand description. So the first number in our instructions will go to according to. So the first number in our instruction is 1. So we'll go over here. Here we're going to look at this instruction since it starts with 1. And let's read the description. It says, load the register R with the bit pattern found in the memory cell whose address is XY. And then they give you an example here. So XY, we're looking at this here, and remember our set of instruction is 1A45. So here this would be XY, and then this would be our register R. So here it says load the register R, so we know that register A, because here R is A, that's going to be stored with the bit pattern found in the memory cell whose address is XY. So here XY is 45. So we're not going to put 45 in here, right? It says we're going to go to the address, right? So we'll go look at the addresses and we'll find 45. And we're going to get the content stored in this address, not the address itself, the content. So here that content would be 61. So register A is going to have 61 in it. And that's our execution step. So our fetch step was just get these instructions here. Our decode step was translating it over here using our opcode operand description. And then the executing was actually doing what the instruction was telling us, so putting 61 into register A. Yeah, and for just to kind of explain how this works more, kind of think about the addresses being like an address to a house, right? And then the content would be like the people living in that house. So this first instruction, all it's saying is, here's our address. Give me the people who live in that address and store it into register R. And here register R was A. Okay, so after we've done the full fetch, decode, execute cycle, we can update our counter by 2 and move to the next place in memory. So we already said before that after we did everything we needed for memory cell AB, the next place in memory we're going to go is AD, right here. Okay, the next set of instructions here would be C0 and 00. Okay, and that's super easy, because if we go here, C00 means to just halt. That means you stop fetching. So here we just stop, right? And remember, the question is, what is the content of register A in hexadecimal when the machine halts? Our machine just halted, and it looks like, based off of this first instruction, register A is going to have 61. See, is that the right answer? Yes. So yeah, that one's a super easy instruction. Luckily, we only had to do the one instruction because we had C000 right afterwards. So that's kind of like a teaser, but there are much more complicated questions. So yeah, that's the answer for that one. Let's move on to a more difficult one. I'm just going to move this down here. Make this a bit bigger. And the answer for this one we should get is 63. So let's see how we're able to get that. Okay, so this question is telling us that assuming the program is loaded at memory, or again, that just stands for memory, the M, BC. So that means we're going to start right here in memory. And then it says, what is the content of memory C8? So that will be this part in memory right here when the machine halts. Okay, let's start fetching our instructions. So our program counter, right now that's at BC. Remember, because the question told us that's where we're loading at. And let's fetch our instructions. Remember, that's 2 bytes. So our instructions are going to be 1F, B, B. Okay, now let's decode what that means. So like our previous example, we're going to load the register R. Again, that one started with a 1. That's why I'm looking here and I know it's this instruction. So we're going to load the register R. So I can kind of just write register. And here, register R is actually F, right? Okay. And load it with the bit pattern found in the memory cell whose address is XY. So this would be XY. So we're going to go there in memory, which is right here. And we're going to get the content in here, AA. So register F gets filled with AA. And I did forget to mention that we're doing this in big byte order. So what that means is you can just write it as you see it, 1F BB. However, if we were doing a little byte order, it would be BB 1F. The lower part, the higher part actually gets put last instead. But we're not, if you were to do BBF1, that's incorrect. That's not a little byte order. That's just a completely different set of instructions. So keep the byte the same, but just put it at the end if you're working with a little byte. But luckily we're just working with big bytes, so we can write it as is. Okay, so that was our first step. Let's increase our counter. So that would be BC plus 2. BC plus 2, that would be BE. And again, we'll just go 2 down. Okay. Let's fetch those instructions. Sorry, I don't know if you can hear that, but my dryer is going off. But give me 1 second. I'll be right back. Okay. So yeah, let's fetch those instructions starting at BE. Again, that's 2 bytes. So our next instruction is going to be 1A C8. Okay, let's translate that. Register R. So in that case, that would be here. Gonna get filled with the content in the memory cell C8. So over here, C8 has 6C in the content. So that's what we're gonna load in our register A, 6C. All right. I'm also gonna put this, I'm just gonna number them too. Okay. So now that we were able to execute that, we can increase our counter again by 2. So that means we're gonna be at C0. And then we're gonna fetch those instructions there. It's gonna be 9EFA. All right. So we haven't worked with this instruction yet because it starts with 9. We've only been working with 1. So let's see what that one says. 9. So I'll go over here because that one starts with 9. Exclusive or the bit patterns in the register S. So whatever that says in our instruction there, and T, and place the result in register R. All right. And then there's a little example there too, but I'll show you exactly what that means. So remember it says exclusive or the bit patterns in S and T. So those registers in this case are going to be F and A. We're going to exclusive or the contents in here. So our previous instructions told us that this got placed into register F and then this got placed into register A. This got placed here. So we'll get those contents and we'll exclusive OR them. It's the same thing as saying XOR. But you kind of can't XOR hexadecimals like that. Like you want to convert these into binary first. So AA in binary, that would be the same thing as 10, 10. So that would be 8, 9, 10. Yeah, and you should be comfortable with conversions by now. Right? And 6C, that would be 6, and then C is 12. So it would be like that. Yeah, because this one is 8 plus 4, and that is 12. Right. And now we're going to exclusive OR them. So the way exclusive OR works is it almost plays by the same rules as OR. Hopefully you guys know bitwise operations like this. So basically, if I have an OR, it's the same as saying plus. So only one of the conditions need to be true for the output to be true. So both a 0 is the same as saying false. So 0 and 0, none of them are true, so therefore the output is false. So it's also 0. 1 or 0, this statement right here is true since it's a 1. So therefore that means that the output is true. And then if the other one was a 1, then it's still true. And if they're both 1, then it's true. The difference between exclusive OR and OR, you would write it like this, is that if both are true, then the statement is false. So exactly 1 needs to be true. Okay, so here only one statement is true, so the output is true. And over here, both statements were false, so output is false. Only one statement is true right here, so our output is true. Over here, oops, over here, both statements are true, so therefore our output is false. So yeah, with regular ORs, if you have 2 ones, you'll get a 1. But with exclusive OR, if you have 2 ones, you'll actually get a 0. Okay, so let's apply that here. So 0 and 0, we said that would be 0. We have a 1 and a 0. That's going to give us 1, a 0 and a 1, also a 1. Now we have a 1 and a 1. So since they're both 1s, that's actually going to give us a 0. 0 and 0 is a 0. Again, we have a 1 and a 1. That means we'll have a 0. And then we have a 0 and a 1. That gives us a 1, and a 1 and a 0. That gives us a 1. All right. So this right here is the result that we're going to end up storing in register R, which we said was E. Let me write that here before we forget. But we can't put binary back, so we got to convert this back into hexadecimal. So this would be C, because that is 8 plus 4, which is 12. And then this is going to be 6. C6. All right. So yeah, we're done with that step right there. Okay, and now we can move on to the next set of instructions. Okay, remember we'll update our counter by 2. So now we're going to be at loading in at C2, which is right here. And let's fetch the instructions, which would be AE01. And we know that we're going to stop whenever we see a C000. That's when we halt. But we haven't seen that yet, so we're going to keep on going. Okay, so this set of instruction is different. We haven't seen an A, and that one's probably a bit more complicated. So let's see what this says over here. Okay, so this says A, so we know we're going to look here. And it says rotate the bit pattern in register R. So over here, register R is going to be E. And surprise, surprise, that's the register we just worked with. Yeah, rotate the bit pattern in register E 1 bit to the right X times. Each time place the bit that started at the low or end at the high ordered end. Okay. So a lot of the times the languaging can confuse students and they might not know what that means. I know when I was taking this exam, when I was first taking the class, this instruction in particular confused me because I didn't understand what it really meant. So let me work this out with y'all. So over here, we have 0x, and this one says 1, so we know we're going to rotate that information just 1 time. So remember we have C6 in register E, so we're going to have to bring that back to binary, but luckily we had the binary up here, so we can just rewrite that. Okay, and it says right here in the instructions, each time place the bit that started at the low ordered end. So we're going to take this bit and then we're going to put that at the high ordered end. We're rotating it. So this is actually going to move in front. So this is going to become 0, 1, 1, 0, 0, 0, 1, 1. All I did was I took that lower bit and I moved it to the front. I rotated it to the front. And over here, it says we do that X amount of times. And right here, it says just one time. So I'm only going to move it once. Just for another example, let's say if I had the instruction AE0 4 times instead, what I would do is I would take 11001110 and I would move this here. That's one time. And then the second time, take the new lower end and move it in the front. And then the third time, do the same thing again. And then the fourth time, one more time. Okay, I moved it once, twice, 3 times, 4 times. So that would be the result for this set of instructions. But luckily, we only had to rotate it once, so this is our actual result for this problem. But yeah, that's how we do that. And this part right here, that's always going to be a 0 because if you start rotating it more, then you just end up looping through the same thing. So yeah, that's how you tackle that problem. Okay, so yeah, now that we've done our rotations with the binary, we need to convert this back into hexadecimal. And then let's see. And then it's still gonna be placed in the same register, right? So this would be the same as 6, and then this is 3. So register E now has 6, 3 stored inside. Okay, so that's that instruction. Let's move on. We're adding 2 to our counter. So now we're going to be loading in at C4. Okay. Let's get our instructions for that one. That's going to be 3EC8. And then this one's a different instruction that we haven't worked with. So let's decode that. So we'll go to 3. Over here it says store the bit pattern found in register R in the memory cell whose address is XY. So register R in this case, that's going to be E, which we just worked with. So we're going to get the contents of register E, which is 63. And we're going to place it in the memory cell whose address is XY. So XY here says C8. So here in C8, we're gonna get rid of this 6C, and then we're gonna rewrite 63. Remember, because it says store the content in register E, which was 63. We know that because we got that here. And then place it in the memory cell C8. So now this is 63. Okay, so we just executed that. And I'll just write the memory here as well. So let's add 2 to our counter. So now we should be starting at C6. Let's fetch our instructions, which is C000. And like we said before, every time you see a C000, that means you stop. Okay, so our program is stopped. Let's remind ourselves the question. What is the content of memory C8 in hexadecimal when the machine halts? Well, we already said that's 63, so the answer is 63, base 16. Yeah, that's the answer we were looking for. So yeah, this one, a bit longer set of instructions, but that's how you work it out. Um, Hopefully I explained some of the more confusing things like the XOR and the rotate. I know the rotate's pretty complicated. Feel free to message me if you're still confused about things, but I'm gonna go ahead and move on. Okay, take a look here. So the answer for this one should be AB. So we'll go ahead and just start by saying our pointer counter. Actually, let me make that look nicer. So let's see what the question tells us. Assume the program is loaded at memory BB. What is the content of memory C5 in hexadecimal when the machine halts? So we know we should be probably storing things in this cell at the end. Okay, but however, we're starting at BB, so I'll just go ahead and start my counter there at BB. And now we can fetch the instructions there. Okay, it looks like we're going to start right here. And then let's get our 2 bytes of instructions. 1, 1, 1, 1. And let's decode that. We already know that 1, we're going to store register R, the memory contents of the cell whose address is 1, 1. Right? And you can just read that in the instructions over here too. Yeah, so the R and the XYs, those are like kind of variable placeholders for your set of instructions. Right? And here it says load the register R with the bit pattern found in the memory cell whose address is XY. Okay, so register R, which would be register 1, actually, sorry. Let's go look at where it says 1, 1. That would be here. We're going to put this content in there. 2A. All right, that's the first instruction. So now let's update our counter. So BB plus 2, that's going to give us BD. So we're going to be loading up right here. And let's fetch our instructions there. That's going to be 1, 2, 1, 2. Okay. This case register R is going to be 2. We're going to load that with the contents of memory cell 12, be 81. Okay. Now we add 2 to our pointer counter. BD plus 2, that's going to give us BF. Let's fetch those instructions there. Okay. That's going to be 5, 3, 1, 2. Alrighty, so we haven't worked with instruction number 5 yet, so let's decode that. Okay, here's instruction 5. Let's see what it says. Add the bit patterns in register S and T as though there were 2's complement representations and leave their result in register R. Okay, so that might confuse people when they throw in the 2's complement there. So basically what it's saying is pay attention to the signs, add them as if you're adding negative and positive numbers, right? And we went over this in arithmetic. So here it's saying add the contents in register 1, that's 2A, and the contents of register 2, which is A1. So we're going to add 2A plus A1. All right. So we're adding a positive and a negative number here. So we should, it doesn't matter what sign we get because there's not going to be overflow. So we can just add them straight together. So A plus 1, that's going to be B. 8 plus 2, that's 10, which is also the same as A. And if that's too complicated for you, then you can also convert these into binary and add it that way. So that would be, that's 2, and then A would be that, 8, and then 1. So if we add these together, we'll get 1, 1, 0, 1, 0, 1, 0, 1. And if we convert that to hexadecimal, this would be A, because that's A plus 2, which is 10. This would be A plus 2 plus 1, which would be B. So we got that. So yeah, basically all you're doing is just adding those together. And then this content is going to be stored in register R, which is 3 in this case. So register 3 has AB. All right. Let's move on to the next set of instructions. Update our counter by 2. That means we're going to start at C1. C1 right here. And let's fetch those instructions, which would be 3, 3, C5. And we already know that this is store that content into register 3. Let's just go ahead and double make sure. Okay, yeah, store the bit pattern found in register R in the memory cell whose address is XY. So we're going to store the contents of register 3, which we said above here is AB, into this place in memory. So memory C5 is going to have AB in it. Remember, that's our content we got from register 3. So here, C5, we'd rewrite that to be AB. Alrighty. Let's update our counter by 2. That should give us C3. Let's fetch those instructions. Oh, look here. Those are our last instructions since we get a C000. So that means we stop. Okay. Yeah, and then the question is, what is the content of memory C5 in hexadecimal when the machine halts? And we already said that the content is AB. Yeah, that's the answer we wanted. So yeah, that's how you do that. That's how we did register 5. So far we've covered register, I'm sorry, not register, that's instruction 5. So far we've covered the instructions that begin with 1, 3, 5, 9, and A. Which ones have we not done? Oh yeah, and then we also did C00, of course. Okay. So this load instruction, instead of going to the contents like in the first one, all we do is we just put the actual bit pattern given to us in that register. So let's say if I had the instruction QE 54, then what I would do is I would put in register E, again, because this is R, I would just put 54, that bit pattern XY. So yeah, The to instruction is much more simpler. Let me see our final example over here. Okay, yeah, we do work with the 2, 0 here. We work with the B, and that's probably what you guys are gonna have questions on. Okay. So if you were to get 8, then you kind of do what we did over here. You convert those to you convert those two contents from the registers given into binary, and instead of XORing it, you would AND it. And that would kind of look like this. So both have to be true for you to get a true output. So these two right here are both false, so you get a 0. Only one is true here, so you get 0, and then a 0 again. But here both are true, so you get a 1. Both are true, you get a 1, and then 0, 0. So that's how AND would look. And then there's the other OR expression. That would look like this. Kind of like what I talked about here. So only one has to be true for it to be true. So that's how OR would look. And I think we added, right? Yeah, we did add. As if there are two complements. Oh, actually, no. This one's different. That's for instruction 5. But for instruction 6, as if they represent value in floating point notation and leave the floating point result in R. I don't know if you guys will have any questions on those, but I don't think you really have to worry about that. But yeah, you would just add them like normally. Okay. Yeah, so moving on to our final question. Let's read this problem here, and our answer should be C0 at the very end. Assuming the program is loaded at MB, what's the content of memory CB in hexadecimal when the machine holds? Okay, so we're starting here. So I can write for my pointer counter B, B. And now we can fetch. That's 1 for A0. So now we know we're going to load register 4 because of this instruction with the contents in memory cell A0. That's right here. So we're going to load 0C in register 4. Okay. Update our counter by 2. That's going to give us BD. Fetch our instructions. Okay, yeah, this is the load I was talking about before. So instead of having to go to the memory cell of 0, 1, all we have to do is just load our register R, which in this case is 0, with that exact bit pattern, 0, 1. Yeah, so that one's easier, more direct. Okay. Moving on to our next instructions, we're adding 2 to BD, so that will be BF. Fetch those instructions. It's going to be 2A10. Okay, so that means we're going to load register A because that's register R, with the bit pattern XY, which in this case is 10. Okay. Next instruction, actually, let me put more space. BF plus 2, that's going to give us C1. Fetch those instructions. BA C9. Okay. Yeah, so this is a different set of instructions we haven't worked with yet. So let's see what that one is. For that one, it says we'll go to B right here. Jump to the instruction located in the memory cell at address XY. So this is an if statement. If the bit pattern in register R is equal to the bit pattern in register number 0. Otherwise, so this is like our else statement, continue with the normal sequence of execution. Okay. So over here, we're comparing our register R, which is A, to register 0. So when you have that B instruction, you're always going to compare a register to register 0, the given register to register 0. Okay. So let's look at the contents of each. So we said in our previous instruction that register A is going to have 1 0 in it. And register 0, according to this instruction, has 0 1 in it. Are these equal? No. So in this instruction says jump to the instruction located at memory cell XY if the bit pattern in register R is equal to the pattern in register number 0. Otherwise, continue. So since this is not equal, we're not going to jump anywhere. We're just going to continue with the normal set of equations. But let's say register A did have 0 1 and register 0 also had 0 1. What we would do instead of continuing on and getting our next set of instructions is we jump to this point in memory. So if they did equal, then instead we would go all the way down here to C9. And then we get these instructions and continue on. But that's not the case. So instead we're just going to continue like normal since this condition did not meet. So we'll update our counter by 2. So we should be at C3 now. Fetch those instructions. A401. And let's decode that. So remember we said A was rotate. Rotate the contents in register 4 X amount of times, which would be 1. So register 4 right now. Let's see, what does that have? According to our first instructions, we said register 4 is 0C. Convert that to binary. C is 12. And now we're going to rotate that last bit 1 time, since this says 1 time. So now the new information in here is this. So this becomes 0, 6, actually. And we place that back into register 4. So register 4 now has 0, 6 in it. Alrighty. Let's move on to the next instruction. We add 2 to our counter. So now we should be at C5. Fetch those instructions there. Going to be another rotate. This time we're going to rotate the contents in A. So in A, we already said that has, I think 1, 0, right? Yeah, 1, 0. Convert that to binary. And then rotate that last bit to the front. So now we'll convert that to hexadecimal, and that is 0, 8. And we'll place that back into our register R. In this case, that is A. There you go. Okay. Update our counter again. We'll be at C7. Fetch those instructions right there. Now we have another jump condition. I know that because it starts with a B. Remember, we're comparing register R with register 0, but in this case, register R is actually 0. So we're saying, is register 0 equal to register 0? Well, yes, because they're the same thing, right? So since they're equal, we're going to go ahead and jump back to the memory cell C1. So instead of continuing onwards, we're going to jump all the way back to C1 over here. So now we're at this part in our program. Let me just erase all these so you don't get confused. Okay, now that we've jumped there, we're going to say our new pointer counter is at C1 because that's where it told us to jump to. Okay, let's fetch those instructions again. And that would be, starting from C1, that would be BA C9. Yeah, so this is kind of acting like a loop, right? Like you're going to do the rotations until finally you register A is going to be equal to 0, and then you'll jump to C9 right here, and that's when eventually you end up exiting the loop, right? Okay, so is register A equal to register 0? So in register 0, we said way before that it has 0, 1 in it. In our previous instruction, we said that the register A has 0, 8 in it now. So unfortunately, these are not the same, right? So we're going to have to continue. We can't jump to C9 just yet, which would be right here. So hopefully by now, you can kind of realize what's happening here. So continuing onwards, we'll just go to our next point. Since this condition didn't meet, we continue as normal. So we update our C1 counter by 2, so now we're at C3 again. Get those instructions. That would be A401. So now we do that rotation again on register 4. Before we said register 4 has, let's see, we said up here that it has 0, 6 in it. We're gonna rotate that one time, so that would be 0, 0, 0, 0, 0, 1, 1, 0. Rotate this over here. And then this becomes 0, 3. So now register 4 has 0, 3 in it. Okay. So let's move on. Starting from here, we add 2 to C3. Now we're going to be at C5. Fetch those instructions there. That is a 0, 1. So that means we're going to rotate everything in register A one time. So register A, we said was 0, 8. We're going to rotate that just once. So now this becomes 0, 0, 0, 0, 1, 0, 0. And this is going to be 4. Okay. So I can kind of tell what's happening here. It's looping. So every time until finally we meet the condition that register A is equal to register 0. So when register A eventually becomes 1 and so when register A finally becomes 0, 1, that's when we'll stop and jump to this example right here. Oops. Actually, let's just continue like normal. So yeah, we did this part right here. So now our counter would be at C7. Oops. Our instructions would be B0, C1. So is register 0 equal to register 0? Yes. So we'll jump back to C1. So we're back here. So it looks like since we're at 0, 0, 1, sorry, 0, 0, 0, 1, 0, 0 for register A currently, after we do this loop, we'll also have to rotate the current number in register 4, which was, we said here. Let's rotate them both at the same time until eventually we get 1 at the end over here. Remember, because we want this register A to be equal to 0. So let's do that. Move this over here. That becomes 0, 0, 0, 0, 0, 0, 1, 0. Move this over here. This becomes 1, 0, 0, 0, 0, 0, 0, 1. Move it, rotate it again. And this one too. So now this becomes 0, 0, 0, 0, 0, 0, 0, 1. And then this one becomes 1, 1, 0, 0, 0, 0, 0, 0. So this is register A. This is register 4. Okay. Yeah, so I'm basically just skipped it, but if that's too confusing for you, then just keep doing everything in order, right? But I already know that this loop is going to keep going until eventually register A equals 0, 1, and now here this equals 0, 1. Hopefully that's not too confusing. Okay. Anyways, so now we'll be at C1 and then we'll do that check BA C9. So since register A is now equal to register 0, we're going to go ahead and jump all the way to C9. Fetch those instructions, which is 3, 4, C7. And I don't think there's actually any like halt here. So actually you would keep going, but since everything kind of like runs out, we're just gonna stop until when we get to the end CC. But yeah, anyways, our counter, we said since we jumped to the condition C9, that's our instructions there. And now we'll decode that. So C is the same as saying store the bit pattern found in register R in the memory cell whose address is XY. So everything in register R, which we said after our calculations would become this, and that is C0. We're going to place that in memory cell C7. Okay, so memory C7 is going to have C0 in it. Okay, where's C7? So instead of B0 here, and let me just erase all this. Yeah, and this one's probably like the longest one, so hopefully you guys don't get stuck with this one, but this is how you do it. So instead of B0, it's going to be C0. Okay. Now we'll continue. Uh, yeah, that was the execution. So now we'll add 2 to our C9. So now we're loading in at CB. Oh, let me read that. Okay, and let's fetch that. So that's going to be 7700. All right. I think that almost meant to change CB. I think that almost meant this to be CB actually instead of C7, so that this one would become C0 and then you would just halt. Mm, yeah, I think that's what he meant. So there's kind of a discrepancy here. So, okay, well, let's see what 7 says. Or the bit patterns in register S and T and place in the result of register R. So S and T in this case would be 0 and 0. So register 0, we already know has just 0, 1, and this is the same thing. And we're ORing it with itself. So that means it's just going to be the same thing. And then we're going to place that into register 7. So register 7 has 0, 1 in it. Yeah, I think Ramos may have made a mistake somewhere there, but yeah, we did get C0 in memory cell C7. I think maybe he meant this to be, no, what did I say before? I think he meant to put C0 in CB instead, not in C7 in that instruction right there. D4C, yeah, 'cause I think this should be CB instead. Yeah, so there might be a typo there. I'll let Ramos know because we actually don't even end up halting the program. So yeah, but that's how you work that out. I hope that wasn't too confusing, but hopefully you were able to see since we have those two jump instructions here, we just ended up jumping back and looping through this iteration again and again until eventually we met that condition that A was also equal to register 0. So yeah, that's how you do that. Um, More than likely you won't get this really long example here, but in that case, that is how you work it out. I'll let Ramos know before he puts on your exam. But yeah, that's how you do it. So that's going to be the end of these videos. Thank you so much, guys, for bearing with me. And if you are watching these videos, then it means a lot that you view these things because I put a lot of hard work into explaining these things. And I just want you guys to do well on the exam because the first exam is the easiest exam. So it only gets harder. So yeah, if you guys are confused about anything, feel free to stop by my office hours on Monday. I'm gonna make myself available for y'all at 3:30 p.m. on Monday, and I'll be there until like 6, just because I have class at 6:30. And then of course I have my office hours on Tuesdays from 1 to 4 p.m. I'll probably stay a little bit extra too if you guys need help. But yeah, that's gonna be the end of these videos. So thank you guys so much, and I'll see y'all later.